All right, we've reached the end of our test. We're at question 12. So question 12 is somewhat of a follow-up to question 11, right? We're talking about continuity. But in particular, it's asking us to find a value of A, so find some value of A that will make h of x continuous. That'll make this piecewise function continuous. Now note here, when we say find a value, this means that there could be more than one, right? So find a value of our constant, right, or whatever we want to call this, our a that we're going to find, our constant. Let's figure out a value of it that will make this continuous. Super simple. So to do this, we are just going to try and verify continuity, right? Same as what we did before. So clearly I might be worried about 1, right? If the expressions change at 1, that's going to be a point where maybe the limit doesn't exist. So 1 is for sure on my list of things to check. Do I need to worry about any other points? Well, here, this is a polynomial, right? Think about a, maybe a is like, for example, 7. This would be 7x plus 3. That's a line, right? That's a polynomial, that's continuous. Cool. No need to worry about any x there. This is also a polynomial, right? It's kind of an x squared term, so it's a parabola. That's continuous as well, right? Polynomials we've talked about are continuous for all values in their domain. So these both would be continuous for the values that are given here, and therefore the only thing I'm concerned about is, like I said, the 0. Or not the 0, the 1, the x equals 1 case. Okay, so let's check out x equals 1, right? That is my cause for concern, x equals 1. What happens? Well, the limit as I go 1 from the left, 1 from the left would be values a little bit smaller than 1, so that's got to be the first expression, right? ax plus 3. That's going to equal, when you plug in 1, a times 1 would be a plus 3. If I solve the right side, 1 from the right, I'm going to do values bigger than 1, right? 1 from the right would be values a little bit more positive magnitude than 1. So I use the bottom expression, x plus a squared minus 10. And what happens when you take the limit as we go 1 from the right side? Well, you plug in 1, you get x goes to 1 plus a squared minus 10. Square that, you get foiled, right? Remember, 1 plus a times 1 plus a, you're going to have to actually FOIL that out. You're going to get 1 times 1, which is 1, 1 times a, and 1 times a would be 2 a's. And then you're going to get a times a, which would be a squared. And then you're going to get the minus 10. So all in all, I'm going to get a squared plus 2a. Remember, I'm going to put this in descending order, make it kind of look more like what we would normally work on. And then 1 minus 10 minus 9. Okay, so I have the limit from the left side, limit from the right side. In order for me to be continuous, you have to have the limit exist, right? Which means the left and the right side would need to be equal. So for the limit as we go towards 1 of h of x to exist, I need a plus 3, which is the left side limit, to equal the right side limit, which is a squared plus 2a minus 9. Okay, and I'm going to try and write this as best I can to make these look like a's and not my 9's. How do I solve this? Well, if you don't think of these as a's and you think of them as like a variable, maybe x, it's a polynomial, right? It's basically a quadratic or a parabola. It's got an x squared term to it. So the way we usually solve x squared things is we try and factor that. Okay, maybe you want to do quadratic formula as well, but let's just get into a form that would actually work for either of those. I move everything to one side, so I'm going to get 0 equals a squared. When you subtract this a to go to the right side, you get 2a minus a, which would be plus a. And then when I subtract the 7 to go over here, I'm going to get negative 9 minus 3, which would be minus 12. I'm going to attempt to factor this. I need two numbers that multiply to negative 12 add up to positive 1. I should have an inkling that this is going to be 3 and 4, right? 4 times 3 would be 12, and then the difference of those is 1. How do I get it to be a positive a, but I get this multiplication to be negative? Well, I do the 4 to be positive, the 3 to be negative. Therefore, the combo would be a positive 1, but the multiplication would be a negative 12. This tells me then for the limit to exist, a would need to be either negative 4, right? Because you're going to set this equal to 0, or a would be 3. Right? So both of those, whichever one we chose, would guarantee that my limit would exist. Now remember, for the y value, because we're checking continuity, you need limit and y value to both be that. The y value of h at 1 would be a plus 3. So no matter what you chose for a in this scenario, right, whether you choose negative 4 or 3, these two things are going to be equal, and it's going to equal the y value because whatever you chose for a made that be that, and that is also this, right? Those are all equal in essence now, no matter what you choose here. So all you had to do for us at this instance was choose an a value and then make your claim that that was going to be the case. So here, maybe I say, all right, at 3, that would be the value that makes this continuous. I would just say, at a equals 3, the limit as I go to 1 of h of x would also equal h of 1, which when I plug in 3, that would be 6, right? So here when a is 3, 3 plus 3 is 6. Here a would be 3, 3 plus 3 is 6. And then if you plug it in here, 3 plus 1 is 4. 4 squared is 16, minus 10 would be 6, right? So you basically just have to show that that limit would be 6, and then say, therefore, h of x is continuous at x equals 1, or just say continuous in general, right? Because remember, that was really the only issue that we had because we said it was continuous everywhere else. So that would be it, right? And then if you want, you could say the same thing for negative 4, plug in and show the same logic, right? Whichever one you made the claim on was your choice. So at negative 4, I'll just do this to show. When you plug in negative 4, you would get a value of negative 1. And so whether you plug that here, here, or here, it was all the same, which means your limit and your y value are both that value. So as you can see, whatever you chose should work out, but big emphasis on no matter what, you had to decide to look at the left side limit and the right side limit and compare those two. Okay? We just follow the same flow of continuity, which means got to verify the limit exists to begin with, got to verify the y value exists to begin with, and then set those two things to be the same if they are. Okay? Cool. All right. That is our question 12. That wraps up our exam. If there are any questions, please let me know.